Okay, so look, what a free body diagram is, it's really just taking an object where there is some force that is exerted on it, and it is showing all the forces that could be exerted on that object. So let's look at number one. All right, and whether you did this in the assignment either online or on paper, okay? If you did it online, it was probably a little bit more difficult for you to be able to write this out, but it was still possible. But the first one, the object is lying motionless. Now, does that mean that there's no forces that are acting on it? There are forces, okay? Just because something is sitting still, acting motionless, there are still forces acting it. What is one force that always acts? Gravity. Okay, so draw the object right here. Okay, and look, you're always going to draw the arrow, all right, with the tail side against your object and the arrow pointing away from the object. So gravity always acts in what direction? Straight down. Okay, some of you, especially on number 6, were drawing gravity in like weird directions. Gravity always acts straight down. So you would draw your arrow just like that. Okay? And then what we'll do is put Fg for the force of gravity. All right? Everybody understand that? Yeah. Okay, now, the other force that's going to be acting on this object, whenever an object is sitting on a surface, and this only occurs when an object is sitting on a surface. So if the object is flying through the air, this does not occur, okay? But when the object is sitting on a surface, whether it's on the floor, on the ground, on a shelf, all right, whatever, there is something that is acting against gravity called a normal force. Okay? Normal force. So we'll just put F in for normal force. Okay? Like, look, I'm sitting in this chair right here. I'm not, like, exerting any energy, really. But I'm also not collapsing to the force of gravity. My body just naturally exerts a normal force against gravity that counteracts the force of gravity. Okay? So that's a normal force. All right. Everybody with me so far? Okay? Now, number 2. The object slides at a constant speed without friction. Okay? If there's no friction, are you going to put a friction force? No, you are not. Okay? So, what force is acting on this box? Gravity. Gravity's always there. What's another force? A normal force, because the object is sliding against the ground. So if the ground is there, it's sitting on the ground, there's a normal force. Okay? Now, are there any other forces that are exerted on this box?
Yes.
What is it?
No.
I would say no in this case, because really air resistance, most air resistance comes in the form of friction. So since it says there is no friction, I would say that you probably would not diagram air resistance here. So in this case, there are no other forces. All right? And some people might say, well, it looks like the box is moving, so there must be a force that's been applied to the box. Yes, there was a force that's applied to the box, but look, it's like this. If I take this chair and I push it, am I still exerting force on the chair?
Yes.
No, I'm not. Okay, I exerted a force initially, but once I let go of the chair, I'm no longer exerting a force on the chair. Okay? So, in that case, there is nothing else acting on this box if we are ignoring friction. All right? Now, one other thing I do want to point out. What should the size of these arrows be? They should be equal, okay? Because if the size of the forces are equal, that means really one of two things. Either the object is not moving, or the object is moving at a constant speed, and it's not changing speed. In this case, the box isn't going up or down, okay? So the normal force and the gravitational force should be equaled out in this case. All right, the next one, you have a box that is suspended by a wire, all right, from the ceiling. So draw your box. Now, what's the force that's acting on the box? Gravity. Always. Okay? And what is the other force? Tension. It's a tension force. Now, why is it not a normal force? Why is it not a normal force? It's not sitting on a surface, okay? So in this case, it's not a normal force. It's not sitting on a shelf, not sitting on the ground, table, whatever. So it's not a normal force. This is going to be a tension force. And there's a couple different types of tensional forces. Like you could have something that's suspended like this. You could also have, like if you're pulling something by a rope, all right, like across the floor, that would be a tensional force also. So right here, this is going to be a tensional force. Size of the arrows should be equal, okay? So right here, you'd put FT for tension, okay? Tensional force. All right, this one right here. What force is acting on this? Gravity, for sure. All right, now, what other force do you have acting? Tension. How many tensional forces? Two. Okay, you have two because there's two wires. Now, here's the thing. How big should the arrows be? That's right, because you have two tensional forces that are actually counteracting the force of gravity. So each one should be about half the size of the gravitational force. So it should look something like that. Does that make sense? Anybody confused on that? All right. Now the next one. What do you have acting on it? Gravity. Always got gravity. Does gravity affect you in space?
Yes.
Yes, it does. Okay? And I'll just touch on that for a minute, all right? So if you watched one of the videos that I sent you guys that I actually talked about in your notes, all right? When it talks about something being shot into orbit, like if you ever hear that statement, what that means is that it's being shot out far enough to where it's being pulled by gravity. However, it's being pulled around the Earth. So it's basically falling around the Earth, and it's constantly being pulled by the force of gravity, but it basically creates kind of like a slingshot effect around the Earth, and it just keeps falling around the Earth over and over. Well, here's the thing. If you're falling inside another object that's falling, you don't really feel like you're falling. Okay? So the video that I sent you guys with the OK Go music video, all right, you guys remember this? So some of you guys caught on to what was actually happening. So let me tell you this. There is no such thing as an anti-gravity machine. Okay? Doesn't exist. All right? Maybe in your dreams, maybe in science fiction. But in reality, the way that they actually simulate anti-gravity, it's really not even anti-gravity. It's just something like it's basically an anti-gravity simulator where basically what they will do is they will have this plane that will fly up, all right, really high, and then the plane will start to descend really quickly. Well, if the plane starts to descend really quickly, it's basically going to be like you are floating inside the plane because the plane's falling. You are also falling inside the plane, and you could do that for a period of time. Now, the plane would have to pull up before it hit the ground, but you can float for a decent amount of time before you actually hit the ground in that case. So that's how they simulate anti-gravity. And that's how they actually shot that video also. Okay, so I don't know how many times they had to actually shoot each one of those scenes before they were able to piece it together. But that's how they would actually shoot a scene like that. So in this case, all right, what other forces do we have acting on this box? We have tension, okay? Now, should each one of these tensional forces be equal?
No. The one.
This is kind of difficult to say exactly. You would think probably more of the gravitational force would be counteracted by this one because it's acting more straight down. You can't really say for sure, but I would say that the top one might be a little bit longer than the one to the side. I'm not going to judge you too harshly on that one, but that's a tensional force. This is also a tensional force, okay? So like I said, this one's probably going to be a little bit longer than this one right here. All right, on the last box. Okay, what's acting on this box? Gravity. Now, some of you were drawing gravity in weird positions, okay? Gravity always acts straight down. So gravity is going to be right here, okay? All right, now what other force do you have? It's normal force. Okay? So your normal forces, you're going to have how many normal forces?
2.
You'd have 2 because it's actually sitting against 2 surfaces, one here and then one here. So your normal force is going to exist right here and then also right here. Each one of those should probably be about half of the gravitational force again. Okay, so it should look like that. All right, everybody with me so far? Anybody have any confusion? Okay. All right, look, number one, I'm just going to tell you this. A book is at rest on a tabletop, diagram the forces acting on the book. This one is literally exactly the same as number 1 on the front. It's just gravitational force acting down. It's sitting on the table. Therefore, there's a normal force acting against gravity. So it's going to look the same as number 1 on the front. Now, number 2 on the front or on the back, a gymnast hangs motionless from the rings, preparing to start his routine. Diagram the forces acting on the boy. Number 2 is going to be exactly the same as number 4. You would have 2 tensional forces from the arms counteracting the force of gravity that is acting straight down. So it's going to look literally the same as number 4 on the front. Now, number 3, a flying squirrel is gliding with no wing flaps. So it's literally just gliding through the air. From a tree to the ground at constant velocity, consider air resistance. Diagram the forces acting on the squirrel. All right. Here's your squirrel.
Your squirrel looks like a king.
There you go. Okay. The flying squirrel. Now, what's acting on the squirrel? Gravity. Always. And what other force? Air resistance. Now, how big should the air resistance be?
The same as gravity.
How do you know that?
Because isn't it thermal velocity?
It says right here that it's at a constant velocity. Now, what if it said that the squirrel was speeding up?
The air resistance would be less
The air resistance would be less than
than gravity.
gravity. If air resistance is the same as gravity, that means that you have reached something called terminal velocity. All right, terminal velocity just means that you're not speeding up anymore, and that's the point where air resistance and gravity are equal to each other. So like, if you go skydiving, you jump out of a plane, all right, you speed up for a while, okay? And you keep going, you keep going, you keep going, until eventually you would reach a point where you would be going really fast, okay? Don't think that you're not falling anymore. Like, you're still falling. It's just you're not speeding up anymore. Okay, that's the point where you reach something called terminal velocity. So in this case, you have air resistance that should be equal to the force of gravity. So put AR, all right, for air resistance there. Don't just put A, because you also have something called an applied force, and you don't want to confuse it with that.
You went skydiving, right?
I did.
Did you have a video you were supposed to show?
I do. Yeah,
Oh, that's what you're doing right now.
it's actually right here. I'll pull that out and show you here in just a minute. All right. Now, last two, okay? This one right here, number 4, okay, says a rightward force is applied to a book in order to move it across the desk at a constant velocity. Consider frictional forces, neglect air resistance, consider or diagram the force acting on the book. All right, so draw your book. Now, what is definitely acting on the book? Gravity. And if it's sitting on a desk, what's another force? Normal. Okay, normal force. Now, this says a rightward force is applied to a book. So what kind of force do you think would be going to the right? This is called an applied force. So we'll put A for applied. And what would be acting against the applied force? Now it says neglect air resistance. So you don't pay attention to that. So what is the other force? When you slide anything across the floor, what's acting against it? Friction. All right. Now, how big should the friction force be?
Less than applied.
Not less. It says it's going at a constant velocity. So what does that mean? That means the forces are the same. Okay, it's not speeding up, not slowing down. So that's the force of friction. So you put FF there. Everybody with me on that? All right. Last one. A college student rests a backpack upon his shoulder. The pack is suspended motionless by one strap from one shoulder. Diagram the vertical forces acting on the backpack. All right. Here's your backpack. It's hanging by one shoulder strap. Now, what are the forces that are acting on? What's one force? Sorry. One force is gravity. Is there friction? You said friction or tension? Yeah, there's going to be tension on the one shoulder, and that's going to be the only other force. Okay? Since it's only hanging by one strap, that means all of the force is focused on that one strap. Okay, anybody have any questions?